Today we are going to learn a fascinating concept in science, which is a force. We are going to see how things move, how things stop, and so many steps. Sometimes we want to take things from one point to another by pushing. So this process requires a force. Sometimes you can cause a motion to an object by using pulling action. For example, if you want to open a freezer, you need to pull. So now we can define a force as a push or pull of an object. And always a force occurs when there is interaction between the two objectives. So when you refer to the measurement topic, so we learned about scalar and vector quantity. So force is a vector quantity because it has magnitude and it has direction. The unit of a force is Newton, and a Newton is a force required to accelerate 1 kilogram mass of an object by 1 meter per second square. So consider this book on a table. So let's say we apply a force of 1 Newton to this book. And a book has 1 kilogram by mass. Then after applying a force of 1 Newton, a book will accelerate to 1 meter or by 1 meter per second square. So this is how we can define a Newton. In physics, you can use a formula to define a certain concept. For example, here, you can define a Newton as 1 Newton is equal to 1 kilogram times 1 meter per second square. So, forces can cause so many effects on an object. So, on the next part, I want to see what are those effects can be caused by a force. When an object is at stationary, or in a simple way, we say an object does not move when all forces are balanced. So if we apply new force on a stationary object which is balanced, so now forces become balanced because there is a new force applied. So the result of unbalanced forces on an object can cause various effects on an object. So now let us discuss those effects. Forces can cause an object to move or to stop. Then forces also can cause an object to change its shape. And it also can cause an object to change its dimension and direction. Now let us demonstrate how force can change the position of an object. So consider this toy here. We can use our hands to stop or to start a motion of this object. Another one is how force can change the shape of an object. Just look this demo. Also, force can change the size of an object. So, for example, you can take a spring and pull it by using your hands. Then you can observe the size will increase. Another effective force can change the position of a moving object. To demonstrate this, take a ball, then when this ball is moving, change the position by using a force applied by your hands. As we explained before, force is a vector quantity. That means has both magnitude and direction. So now is a part of explaining the magnitude of the force. Magnitude is the size of the force applied. it is always measured by an instrument of the spring balance. So now we are going to see by our naked eyes a spring and how it works. So always it operates by using Hooke's law. So Hooke's law means the elongation of the spring is proportional to the load supported by a spring balance. So in simple way, you can say the size of the springs or length of the springs will increase due to the size of the load applied. So for example, if we put this load of the spring, so it is different when we put a heavy load on the spring. So a spring balance, it has a spring attached to one end, and on another end there is a hook for attaching a load to be measured. So always it is covered by metal case, and it has a pointer to read a Newton or the value of the measured object. So there are two forces applied to this Hooke's law, and those forces we're going to discuss them later. So the most important thing now is to know what is the spring balance and how it works. So it has those newtons